Hey everyone, it's Mr. Montgomery again, and today we are going to be going into electromagnetism, and this is going to be like some introductory material about it. So we're going to go over some important key terms and give you a pretty good basic understanding about it before we go into more complex concepts. So I do have this really cool video where you could even do this at home, really. All you would need is a AA battery or AAA battery, some very small round magnets, and a copper coil. So I'll play for just a little bit so you guys can check this out. And I'll explain it afterwards. Here we go. So check this out. Make sure you have magnets on each side. And as long as you have those magnets, you have the power source and this coil, something really cool happens. So of course he's not pushing it super hard to just shoot it through. It's actually moving itself through the coil. See? And this is something that we call induction. If there is a magnet and a conductive coil like copper, when you put those two together, they actually do make an electric current. So since they're creating electric current, they're also being displaced by the other power source involved, which is the battery. And that's what's forcing it to move all the way through around this coil, and they're making like a little racetrack. So all that is thanks to induction, which we're going to go into more depth about later on. Alright, so after today you'll be able to explain some properties of electromagnetism and how it impacts our everyday lives. So, what exactly do you think electromagnetism is? If you had to pick one of these choices to, for explaining it the best way possible, which one do you think it's going to be? It explains how magnets can power an entire house, explains how power plants conduct electricity, or electricity producing a magnetic field. So did you pick an answer? Okay, I'm hoping you did, because that's kind of the point. It gets you thinking a little bit about which one of these could possibly be the correct answer to help explain electromagnetism, and the correct answer is this bottom choice. Electricity, it produces a magnetic field. So if you have a battery and a copper wire and make a little quick circuit, that wire will produce a magnetic field the entire time there is an electric current flowing through it. And you could even try this out with a compass. If you make a little circuit, put a compass near it, that needle that's normally pointing north is going to be flipped around to point a different direction. Okay, so the basic definition of electromagnetism is when an electric current produces a magnetic field, just like we discussed. And you will be seeing this picture a few times more, so I'm going to break it down really quick. So you have your power source, the battery. This black line is the copper wire. Don't worry about this little piece there. That's not going to worry about it. And then whenever you see these little squiggles in a circuit, they count as resistors. But don't worry about that too much. We're mostly just going to focus on the battery and the circuit itself. Okay, so how do we know it's even there? Where is it? We can't see a magnetic field that is being produced, but we can observe its effects, which is really cool to see. So, for example, like I mentioned earlier, in this picture you have a 9-volt battery, you have a thin copper wire going around completing a circuit, and this wire is surrounded by compasses. And you can see that the compasses have the little red part of the needle is pointing kind of like in a circle. They should all be pointing the same direction, really. But they are instead making a circle because it's being displaced by the magnetic field of that copper wire. And also, hotel key cards use a little machine to help magnetize it so you can access your room. But of course, they are doing way better jobs with those key cards today than they used to, because back in the day when I was younger, If you ever put one of these key cards next to your cell phone, it would be erased and you wouldn't be able to get into your hotel room, and you would have to go get a whole brand new card made for you. Whew. Good times. All right. So since we're talking about electromagnetic fields, I thought this was just a fun question to ask. Let's see how much you know about outer space and electromagnetism. Which one of these planets do you think has the strongest electromagnetic field? Is it Earth, Jupiter, Mars, or Venus? Right? If you said Mars, well, you're not correct. We can get to Mars pretty easy. If you guys have kept track of anything with science and Mars, we have sent many rovers over there. We have a rover over there currently, and we're even going to be able to send people there very, very soon through SpaceX. And if you said Venus, yeah, that's also not correct. We have sent things there before, but they just don't last because of the highly acidic atmosphere. It rains acid. Super crazy stuff. If you said Earth, well, it does have a magnetic field, but we live on Earth and we deal with it, and we can also still use electronic devices within our electromagnetic field and not have it disrupted. But Jupiter, on the other hand, we've sent many probes over to Jupiter, and every time they get a little too close, its super strong electromagnetic field shortens out every probe, and it turns into a super heavy paperweight. A very, very expensive super heavy paperweight. All right, so how was it discovered? Well, one person that helped contribute to the discovery of it is a Danish scientist. He sent a electric current back in 1820. He did all this, right? Sent electric current through a wire and noticed that it affected his compass. And that kind of went in through a whole bunch of experimentation. And also Michael Faraday did some experimentation with this as well, when he realized that if you wave a copper coil over a magnet, it does produce a electromagnetic field, and electricity is produced. But we're going to go to that later on, where we talk about induction, and induction's pretty wild. That's actually how we get all the electricity we use today in our homes. Okay, so let's see who was paying attention, and we're going to do a really quick check-in. What can produce a magnetic field? Is it mass, gravitational forces, only more magnets, or an electric current? And I'm hoping you picked one of those answers. Hopefully you're paying attention to the video and you know exactly which one is correct. And it's going to be an electric current. Remember, so I'm saying that if you complete a circuit, that wire gives off a magnetic field the entire time it's happening. And we saw that picture of the compasses being disrupted by that magnetic field. Okay, and I know there's choices over here, but it already has it kind of spoiled for us. So there are some main traits when we talk about man-made electromagnetic fields. There are three main traits, in fact. And the reason I'm saying man-made electromagnetic fields is because, well, Earth has an electromagnetic field and we can't control it. So it doesn't exactly follow these same traits that we're going to be talking about. So the first trait is the electromagnetic field can be shut off for any man-made electromagnetic field. There's always going to be a switch in place, or if there's no switch, guess what? Take away the power source, and the electromagnetic field is turned off. So if you think back to that picture with the battery in the circuit, if you took that battery out, it's off. And I just got done explaining this. So if we were in the classroom, I'd have you guys type up your answers to make sure who is paying attention, but I did just explain this. I feel, a little silly having you guys try to reiterate the exact same thing I just said. So I'm just going to repeat it. So how would you turn off the electromagnetic field in this picture? Well, we just mentioned that there's no switch, that you could take away what? The power source. So what's the power source in this picture? The battery. This AA battery right there. Take that out. There's no more magnetic field being produced by that wire, and you have shut off the electromagnetic field. Okay, trait number 2, you can reverse the direction of the electric current. So, How would you reverse the direction of the electric current in this circuit displayed in the picture? Would you flip the wire, flip the battery, or flip the wire and the battery? Okay, hopefully you picked one of those choices, trying to test your brain a little bit, and all you'd have to do is flip the battery around, and you would change the direction of that current. Okay, trait number 3, the strength of an electromagnet or electromagnetic current can be increased or decreased. Well, we can do that with the power source, right? If we have a AA battery, we're only sending 1.5 volts through, and it won't be as much power going through to produce that magnetic field. So if you were to create an electromagnet with an iron screw, and you only have a AA battery, yes, it's going to work. But if you have a 9-volt battery instead and increase the power for that solenoid to redirect all those magnetic domains, well, you're going to have a much stronger magnet. Okay, so how can we change the strength? Well, first we can change the power source, right? We can either have an alternating current or increase the voltage of the direct current that we are using. Another is to loop the wire like a coil. And when we do this, we call this a solenoid. And it greatly increases the electromagnetic field and will allow you to create much stronger magnets. So in these 3 pictures, we see some circuits and some copper coils and stuff. Which one has the strongest electromagnetic current? Is it picture 1, picture 2, or picture 3? Okay, I'm hoping that you already have a picture selected. If you said the first picture, well, that can't be right, because even though it's a copper coil, it's wrapped around wood. That's not going to give you any kind of power. No electromagnetic field. If you said this third picture, you're getting closer, but it's just a single circuit. There's nothing special that they really changed. And the power source, it looks like a C or D battery. It's just 1.5 volts. So although it will produce an electromagnetic field, it's not the strongest one here. The strongest one is going to be this middle picture. Why? Because there is a copper coil. We just learned that can increase the electromagnetic field, and it can help align all these domains in this iron nail and make it into a nice, powerful magnet. The more coils you have, the stronger the electromagnetic field. So, as I mentioned before, when we coil a copper wire for electromagnet, we call it a solenoid. And this increases the electromagnetic field greatly. The more coils you have, the stronger the electromagnetic field is. Okay, and here's an example of how solenoid is used today. So if you go to like a junkyard and you have these huge cranes with these big electromagnets moving cars around and stuff, right? You have a ferromagnetic core, which is usually iron. Iron is a great material that we use all the time, and we can easily manipulate all those magnetic domains inside to make it into a nice temporary magnet. And if we shut the power off, it's not going to stay a magnet because the domains are so easily shifted back and forth. So we don't have to worry about it becoming permanent and staying active the entire time. It makes it so we can easily shut it off and on and use it as we need to. So just remember, you have a solenoid wrapped around a ferromagnetic core. So you have that copper coil wrapped around some iron. Oh, and here's a little video of it working. So you can see that there's nothing coming off the trailer here until he lowers all the way, and he hits a switch on the inside, lifting everything to that electromagnet. And then he shuts the switch off, it drops everything off of there, and now he can drag it back over. See, nothing's moving yet. And as soon as he flipped that switch inside, you just see everything flying straight up off that trailer, right to that magnet. So that's the really cool thing about the electromagnets that we make. We always have that power switch, so we can do so many different things with it. Because if he kept it on the entire time, well, he would probably get that magnet stuck to the trailer and maybe start lifting up the entire trailer or the truck itself, and that would just be a mess. All right, so that's it for today's lesson, guys. I hope that this was helpful if you're using it to review, or if you've never learned anything about electromagnetism before. I hope that this taught you something you didn't know before. So next time we're going to dive into more complex terms with electromagnetism, and we'll see you guys at the next video. All right, have a great day, and I'll see you later.